What's up everybody, I am back with another Leetcode problem number 763. The problem is very simple. It is about the partition labels. Let me read out the problem first. You are given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part. For example, the string AB, this is ABCC. Okay, so basically it is very simple ki if A occurs in this partition, it cannot be over here. Okay, if C is over here, similarly C cannot be over here. So basically we can for the optimal solution we can use the hash map. First and foremost we have to declare the hash map. It is the example given. Let's see the approach actually first. We can first this solution will be in two parts. Okay, that is two pass. First pass, in the first pass we have to calculate the frequency of each character and load it into the hash map. Okay, we are using the hash map. We can keep the name of the hash map as last index, that's it. So in the next pass we will perform the main operation. First and foremost we will declare three variables, that is for storing the main result, for keeping track of the size of the subarray, and another variable, that is end. We will be storing over where we will be storing the last index of occurrence of that particular character. Okay, in the hash map we are actually storing the character. First the key will be the character obviously, and the value will be the last index of the occurrence of that particular character. Okay, so this is all about the approach. Let me first code it up. It will be much more clear to you. So actually it is a medium grade problem, but I will say it is quite easy, and we will be solving it in O of 1 space complexity and O of n time complexity. Okay, so let's type the comment first. Let's comment it out. We will be keeping track of the last index of the character. Okay, we have to calculate the frequencies basically. So keeping the track of the last index. Okay, so this is the thing. Last I will keep it as hash map. It says hash map is equal to for I, we have to keep the track of the index of that particular character. I index and the character in enumerate of S. Okay, we can just remove this. Hash map. It's hash map of character is equal to we are actually keeping the track of the last occurrences of that particular string. Okay, it will basically store that part. Actually it is the pass one that I have already explained. This is the pass one. Next we are moving forward with the second pass, the main operation. It will be the main operation. ATION operation. So we will be declaring the three variables, that is res is equal to, for storing the main result, the size, for keeping the track of the current subarray, size of this current subarray. Okay, end will be like we are keeping track of the particular ending index of that character, so I will declare it as 0. Now we will be traversing through the character. So for I comma c in enumerate of s. Now there will be some conditions over here. As we traverse the character, we will be incrementing the size as usual. Okay, as usual, is size plus equal to 1. Yeah, the condition will be if the hash map of the if the value of the index of that character in that is stored in the hash map is greater than the current end, we will be modifying the end value. Okay, that is if the let's consider an example. That is let's consider an example. It's an example. Okay, so basically we have something like a 7. Okay, and our end is the current end is equal to, for an example we are considering an example 6. Okay, over here we can find that end is smaller than this value. Okay, so we will be modifying this variable. Okay, so basically if hash map c is greater than is greater than end is equal to hash map of c, hash map of c. Okay, we have just modified that. Now during this operation, what will be the ending case? Ending case will be like if for some instance I am considering it as the current index that we are in, that is the value of I is equal to for an example 7. Okay, and the end value is also 7. End is equal to 7. In this condition, we will be just storing the current size into res, and we will be resetting the size value. Okay, we will be resetting the size value. So this is the condition for the exit portion. So let's code it up. If I is equal to end res dot append size, the current size of the subarray. Okay, size, and we will be resetting the size variable also for the second pass. Okay, for again performing the same operation in the second pass. Okay, so basically size is equal to 0. At last we'll be just returning the result, return res. Okay, let's run the code. Okay, the test cases are passing, it's quite good. So let's submit it. Okay, this is quite efficient. Actually the time complexity is tc is equal to O of n, and the space complexity is sc is equal to O of 1. Okay, So this is quite efficient solution of this problem, and this is all about the problem.